Good day, everyone. My talk is entitled Enhancing Student Performance Through Laboratory-Based Instruction, a study on the relative density and buoyancy of liquids. This is my outline and this is my abstract. Now, public secondary high schools in the Philippines do not have a science laboratory course that complement their lecture course, not even in the science, technology, and engineering and mathematics STEM curriculum. Besides, science equipment or apparatus is often not available. That is why teaching science can be tricky, especially when it comes to topics like how and why things float in water and other things. Many students find this confusing even after studying it in the class. Thus, we wanted to see if doing experiments in the lab could help students understand this topic better and identify the underlying factors influencing these outcomes, which could provide deeper insights into the efficacy of the intervention. So this study answers the following questions. What is the mean pre-test and post-test performances of the control and experimental group? What are the mean gain scores of the control and experimental group? Is there a significant difference between the pre-test and post-test performances of the control and experimental group? Is there a significant difference between the gain scores of the control and experimental group? And what are the factors contribute to the significant performance in the laboratory method? So the null hypotheses are first, there is no significant difference between pre-test and post-test performances of the control and experimental group. And the second null hypothesis is there is no significant difference between the gain scores of the control and experimental group. This study employs a descriptive quasi-experimental design, now utilizing a 20-item teacher-made test. And then the respondents are the 100 heterogeneous students in one of the secondary high school in Cantilan, Surigao del Sur, and they were grouped into control and experimental groups. For the statistical test, the paired t-test was used to test if there is a significant difference between the mean pre-test and the post-test scores of the control and experimental groups. The t-test for two independent samples was also used to test if there is a significant difference between the mean gain scores of the control and experimental group. And we also used multiple regression analysis to determine the factors that affect students' performance in both groups. For Table 1 shows the pretest performances of the control and experimental group. As shown in the table, the pretest mean score of 13.032 of the control group shows a slightly higher value compared to that of the experimental group with 11.357. This means that the control group performed better during the pretest. Additionally, the computed standard deviation of the control group is 1.7553, which is also a little less than the experimental group of 2.0380. This implies that the scores of the respondents in the control group are more clustered to its mean compared to that of the experimental group. The table also shows the post-test performances of the two groups. The control group obtained higher post-test mean of 14.226 than the 12.821 of the experimental group. This means that the control group displays a better performance than the experimental group during the post-test. However, with a higher standard deviation value of 2.0148 of the control group, it demonstrates a more dispersed set of scores than experimental group with 1.8096. Further, this implies that there are respondents from the control group with extremely higher scores and contributed to the group's higher post-test mean scores. This findings is aligned with the work of Aulia in 2018 and Tarhan in 2010. Table 2 shows the mean gain scores of the control and experimental group. As shown in the table, the experimental group obtained a higher mean gain score of 1.4643 than that of the control group with 1.1935. This implies that the respondents in the experimental group have a better gain performance compared to the control group. Moreover, the smaller standard deviation of the experimental group 1.2048 implies a better set of scores clustered close to the mean compared to the more dispersed set of scores in the control group with a standard deviation of 1.6164. This confirms the work of Shousin in 2023. The magnitude of change between the experimental and control groups is approximately zero point 0, rather 0.27, which indicates that the experimental group experienced a slightly larger improvement in the performance compared to the control group after the intervention. The experimental group received a targeted intervention. Perhaps this intervention was effective but not dramatically so, resulting in only a slight improvement. Table 3 shows significant values of the difference between pre-test and post-test performances of the control and experimental group. The computed p-value during the pre-test is 4.364 and has a corresponding p-value of 0.000, which is less than the 5% level significance. Thus, the null hypothesis is rejected. With this result also, it is inferred that there is a significant difference between the performances of the control and experimental group during the pretest. Additionally, the computed t-value and p-value during the post-test are 4.257 and 0.000 respectively, with p-value which is less than the 5% level of significance. The null hypothesis is rejected. Thus, there is a significant difference between the post-test performances of the control and experimental group. Table 4 shows the significant values on the difference between gain scores of the control and experimental group. As shown in the table, the computed t-value is 4.84 with a p-value of 0.000. With a p-value less than this 5% level of significance, the null hypothesis is rejected. Thus, there is a significant difference between the mean gain scores of the control and experimental group. Further implies that the experimental group shows significantly higher than scores than that of the control group. It is also infers that the method applied in the experimental group can significantly contribute in increasing performance of the students compared to the method applied in the control group. Further, while analyzing pre-test and post-test performances and gain scores provides valuable information, understanding also the underlying factors influencing these outcomes provides deeper insight into the efficacy of the intervention. The F value of 4.21 is significant at a level of significance alpha equals 0.05, which means that there is a significant relationship between grades and the factors, namely the difference in the post-test and pre-test scores, the attitudes of the students towards physics and the laboratory method, and the teacher. Specifically, since t-value for attitude is significantly at alpha equals 0.05, the variable attitudes affects the grades of the students. So observations following the laboratory experiment yielded promising results rather a discernible improvement in the student performance was noted with a statistically significant increase observed in post-intervention assessment compared to the pre-test. So therefore, in the ever-evolving landscape of educational methodologies, laboratory-based instruction remains an enduring and indispensable laboratory approach, for imparting scientific concepts. So these are the references.